In this video, we'll be discussing what an exponential function is and how it can be applied to real-life situations. An exponential function with a base of a is denoted by a to the x, where a is a positive number and a cannot be 0. So, an example would be 3 to the x, 1/2 to the x, 0.7 to the x. These are all exponential functions. The reason you cannot have a as a base of 1 is if we had the function of 1 to the x and we were to plot this. 1 to the 0 is to 1. 1 to the 1 is 1. 1 squared is 1. 1 to the third power is 1. 1 to the fourth power is 1. 1 to the fifth power is 1. 1 to the sixth power is 1. 1 to the negative 1 is still 1. 1 to the negative 2 is still 1. So you would just actually have a horizontal line at 1. This is not an exponential function. So that is why a cannot be 0. And at the moment, we are not dealing with negative numbers to show what they do. At the moment, we're only dealing with positive numbers. So the exponential graph, when a is greater than 0, the exponential graph of when a is greater than 1, for example, 4 to the x, 2 to the x, 1.5 to the x, 10 to the x, are all going to have graphs that look very similar to this. They will all cross at 1, and the reason is because any number raised to the 0 power, if x is 0, so if x equals 0, any number raised to the 0 power is the number 1. And so that's why every exponential function graph, the parent function, for example, is going to cross at 0, 1. And then depending on how large the base is how exponentially it is going to raise up the graph. Now, if a is a fraction in between 0 and 1, for example, 2/3, 1/2, 1/4, this will happen. Again, they do cross at 0, 1 because even when we have 1/2 raised to the 0 power, it is still going to be the number 1. Now, all of these actually decay. So if you think about it, if you start with $100 and you take half of that, you're down to $50. If you take half of 50, you're down to $25. If you take half of 25, you're down to $12.50. Then you're down to $6.25, and so forth. And so if you think about a function that is less than 1, greater than 0, but less than 1, if you think of like a half-life, when you're talking about in physics or chemistry, that is going to make a graph decrease because you are decaying in amount. Now, there is something called the natural base, e, that we have discussed in past videos. E is a number. It is a constant, 2.718. Obviously, it goes on forever just like pi does. And the natural exponential function is the function e to the x. So if you think about growth and decay, one of the familiar examples is what happens with those if you have money that is put into an interest rate and it is going to grow, or if you have a radioactive element and it is going to decay. This is where you would notice that things are going to grow, like the population doubles or grows by a certain percent. Or if you have something that is decaying or depreciating, then the graph is going to decrease. So if you notice the bases, if the base is bigger than 1, then it is going to increase, the graph will. If the base is between 0 and 1, the graph will decay. Now here are the simple growth and simple decay formulas. R is the rate of growth or decay. Same thing here. P represents the initial amount, and A represents the final amount. So for example, this would be a growth. Why? because this number is bigger than 1. Growth because this number is bigger than 1. This would also be a growth, again, because 1.5 is bigger than 1. So these are both growths, which means the graph will increase. These would be considered a type of decay. Why? Because 0.95 is less than 1. Same thing here. This is also a decay because 0.87 is less than 1. Now, we can actually talk about how much it grows or decays by. If this number is represented by 1 plus r, then we know that we can subtract this from 1 and we will get the amount of growth. So 1.025 minus 1, obviously, is 0.025. And you always represent growth and decay normally as a percent. And so if you move the decimal place, then you would say, in this case, this grows by 2.5%. This one, if you take the number and subtract 100% of the number, you would get 0.5. And if you move the decimal over 2 places, you would say that this grows by 50%. This one is a decay. Now, a decay is a 1 minus r. So if you subtract 1 minus 0.95, so this decay, this amount, 10,000 bacteria, let's say, it is not decaying 95%. It is actually decaying 5%. It decays by 5%. Do not take this number and say that that is the percent. Don't do that. You need to subtract from the 100% that you start with. So the 0.95 means that it decayed by 5%. Same thing here. If you subtract 1 minus that number, then you would get 0.13, which means this exponential function is decaying by 13%. So, for example, given the following exponential function, identify whether it represents a growth or decay and then what percent of rate of increase or decrease. So if you look at the number that has the exponent, always look at the number that is raised to an exponent. Is it bigger than 1? Yes, so it is a growth. And then by how much? So if you subtract this number from 1, you will get 0.01. And if you move the decimal place twice, it should be 1%, which is correct. So another one. If you look at the number that is raised to the exponent, first, is this bigger than 1? No. Therefore, it is a decay. And then by how much? Do not put 96%. It is not. Remember, you need to subtract from the 100%. And so 1 minus 0.96 is 0.04, which, as a decimal moved to a percent, it becomes 4% decrease. Growth and decay formula. These are the growth and decay formulas. Simple interest and the simple depreciation or decay we have already discussed. The two other ones that we will use to talk about will be the compound interest and the compound continuously. The letters that represented are down here. A represents the final amount. P in every one of these represents the initial amount. R is the rate, always as a decimal. The R, if it comes to you as a percent, make sure you always you always put it as a decimal, not a percent. T represents time, where it's minutes, years, months, it doesn't matter. N represents the number of times compounded. So if you ever have something that's like compounded quarterly, that means you would have a 4 down here in the bottom, and you want to multiply 4 times the amount of time. If it was monthly, then you would write the number 12 here for n because there's 12 months in a year, and n up here would be 12. Semi-annually means twice, semi means 2. Other ways you could say is if it said daily, then you would use the number 365. If it said compounded weekly, then you would use the number 52. So, for example, a new car is purchased for $24,500. It depreciates at 7.25% per year. How much will it be worth after 5 years? Depreciates means that you will use the formula 1 minus r raised to the t. We know the initial purchase was $24,800, and the rate is 7.25%. But remember, you got to move it and make it a decimal. So you got to move the decimal place twice, leaving you 0.0725, and then raise to the amount of time, and it was 5 years. And if you put that whole thing in the calculator at the beginning, you will get $17,022.42. The fact that it says depreciate means you need to subtract from the original 100%. Next, an element with a mass of 930 grams decays. Again, decay means depreciation. So again, we're going to use the formula 1 minus r raised to the t. The initial amount of grams, or the initial amount of element, was 930. It decays at 15.6%, which means we move the decimal place twice. And that is happening per minute. And then to the nearest gram, what is the mass of the element after 20 minutes? So the amount of time that has elapsed is 20 minutes. If you put this entire thing in the calculator, you will get 31.28 grams is left after 20 minutes. A total of $12,000 is invested with an interest rate compounded quarterly. So automatically, we will use the formula 1 plus r over n raised to the nt because it is compounded quarterly. The initial amount invested is $12,000. We place that for P. The rate, remember, make it a decimal. And then quarterly means 4 times a year because there's 4 quarters in a year. So you would divide by 4. And then you would raise it to the n times t. Well, it's happening 4 times a year for 5 years, which means it happens 20 times because it happens 4 times for every single year. So after 5 years, that means it happened 20 times. If you put that entire thing in the calculator, just like it is written, you will get 13,934.21 cents. Now, that is the first part, is how much money will be in the account. Now they want to know how much interest was accrued. That means if you started with 12,000 and now you have 13,900, then subtract from your initial investment, and that would be how much interest alone you gained. You're going to invest in an account that has an interest rate of 4% compounded monthly. So automatically you're going to use the formula 1 plus r over n raised to the nt. You actually do not know how much you need to invest initially. That's actually what it's asking for. So we're going to leave P by itself, or P alone. The interest rate is 4%. Do not forget to make sure you make it a decimal. Compounded monthly means that you have compounded it. It means it's happening, or the interest is happening 12 times a year. And then you want to know, let's see, how much money do you need to invest in order to have $1,000 in the bank or in the account after 5 years? Well, if it happens monthly, that is 12 After 5 years, that means it happens 60 times because it's happening 12 times a year for 5 years. So it happens 60 times. So in order to solve this, you can go ahead and put this part right here in the calculator and you will get 1.22099,659. And then to solve for P, you would divide both sides by that and you will get $891. So this means that you need to invest $891 so that 5 years later, you will have $1,000 in the account. A culture of bacteria has an initial population of 600 and doubles every 2 hours. Using this formula, so in this case, they actually give us the formula because we have something that is doubling. It's not just growing at like 2%. It's actually growing at 200%, technically, if you want to think about it like that, because it's actually doubling every 2 hours. So P of O is your initial amount. So you have 600 bacteria initially. And it is doubling, which is why you're multiplying 2 raised to something. Because basically it means that you have 600. So after 2 hours, you're going to have 1,200. After 2 hours after that, you'll have 2,400. 2 hours after that, you'll have 4,800. It's happening every 2 hours. And so T represents the number of hours. D represents the doubling time. So the fact that it's happening every 2 hours, that is your D. The doubling time, every 2 hours is the doubling time, so T. And they want to know what is the population after 19 hours. So that is the amount of time that has elapsed. So if you plug this whole thing in the calculator, you will get 4,344,46.4, which would be the population of bacteria. Because if you think about it, 2 goes into 19 about 9.5 times, and so 600 is doubling it a little over 9 times, which is why you can get a very large number in a very short amount of time.